have already completed these marked portions, and the thing which is left right now is the graph. So let's see what is graph. By the way, we have also seen the linear nonlinear implementation of C. Let's see or not. So only thing which is left is graph. So that is our topic of discussion today. So what are graph? Graph can be defined as a group of vertices and edges that are used to connect these vertices. What are vertices? These are vertices. These points are vertices. So this graph is having how many vertices? It is having 5 vertices. And these are connected with the help of these edges. These are the edges. 3, 4, 5, 6. How many edges do we have? We have 6 edges. So what is a graph? A graph is a group of vertices and edges that are used to connect these vertices. Now, definition of graph is already mentioned over here, which I have just now explained. Now this graph is an undirected graph. Here you do not have any direction associated with your vertices. So a graph can be directed or undirected graph. In an undirected graph, the edges are not associated with the direction, as you can see over here. Now if it was a directed graph, in that case you would have we would have given you some kind of direction. There would have been some kind of direction. It can be multiple direction also, that doesn't matter, but there would be some direction associated. Now in an undirected graph, if an edge exists between two vertices A and B, then it can be traversed from B to A as well as from A to B, as in this example. As you can see, since it is an undirected graph, so you can either move from A to B or you can move from B to A. So in both ways the flow is possible. But in a directed graph, the edges are ordered and the specific path is given to you. Over here, since I have a direction over here, I can only move from A to B, but from B to A it is not possible. From B to A is not possible. So this is not possible. Only A to B is possible. Again, B to C is possible. Now there are few terminologies that we need to know. The path. A path is defined as a sequence of nodes that are followed in order to reach some terminal node B from initial node A. So the path over here, this is the path. If I want to move from C to D, what is the path? From C to E into A. So this is my path. What is a closed path? A path that is called if the initial node is same as the terminal node. If the initial node and the terminal node is same, then it is a closed path. So over here, as you can see, if A is the initial node, it moves to B, B to D, D to again A. So it is a closed path. A simple path, if all the nodes of the graph are distinct with an exception of our initial and the final node, then it is a closed path. So it is a closed path. These are closed paths. Simple path. What is a connected graph? A connected graph is the one in which some path exists between every two vertices. There is no isolated node between them. As you can see, there is no isolated node between them. If there is isolated node, then it is not a connected graph. It is a what is a complete graph? Every node is connected with all other nodes is a complete graph. Every node is connected to all other nodes is a complete graph. So in this case, it is not a complete graph. Why it is not a complete graph? This node is not connected with D. So there is no connection. If there is a connection, in that case it is a closed graph. If since over here it is not, hence this is not a closed graph. Closed graph. What are weighted graphs? Now in certain graphs, along with the direction, some values are associated with it. Suppose we will give you some value of 5, suppose 2 or 1, some value will be associated. If a value is associated, then it is a weighted graph. What is digraph? A digraph is a directed graph in which each edge of the graph is associated with some direction and traversing can only be done in a specific direction. That's a digraph. So all the edges, they will be associated with one direction and it can only traverse one direction. So that is what is a loop? An edge that is associated with some similar endpoints are called loop. So there is a looping. Adjacent nodes, as you know, the nodes which are adjacent to each other are adjacent nodes. Degree of a node is the number of edges that are connected with that node. Suppose over here, what is the degree of this node? E. The degree of E node is 1 because it is associated with this. What is the degree of A? It is 1. What is the degree of B? It is 2 because it is connected to 2. So degree 2. A node with 0 degree is called isolated node. So if there is nothing, no connection, then it is an isolated. Now graph representation. What is graph representation? It simply means the techniques which we used in order to store some graph into the computer's memory. So basically there are two ways of storing the graph. One is the sequential way representation, where we use the adjacent matrix to store the mapping of vertices and edges. Suppose this is suppose this is my suppose this is my undirected graph. Now since this is my undirected graph, how many vertices do I have? I have 5 vertices. As you can see over here, A, B, C, D. I have 5 vertices. Since there are 5 vertices, so this is a 5 by 5 matrix. Now in such kind of 5 by 5 matrix, we need to see what is the connection between them. See over here, I is connected to B, isn't it? Now this is not a directed graph. Since this is not a directed graph, hence B is also connected to A, isn't it? Since this is not a graph, so B is connected. As you can see over here, A is mentioned over here, B is mentioned over here. Since A is connected to B, so we have 1 written over here. So A is connected to B. Similarly, my B is also connected to A because this is an undirected graph. Hence, I can see from B to A also I have 1. Similarly, from B to C, this is connected. So B and C, it is connected. Similarly, C is also connected to B. So C is also connected to B. So in a sequential representation, we use the adjacency matrix to store the mapping represented by the vertices and the edges. A graph with n vertices will have n into n dimension. As you can see over here, there are 5 vertices, so it's 5 by 5 matrix. In an undirected graph, as I have just shown to you, there is a both way connection. If D is related to E, similarly E is also related to D. So D is related to E, hence 1 is over here. Similarly, E is related to D, hence 1 is over here. Now what about directed graph? In the directed graph, a direction will be given to you. Here my A is connected with B, but B is not connected to A. So as you can see, from A to B there is a connection, but from B to A, see, it is 0. There is no connection because there is nothing. So in this way, these directed graphs are done. Now there is also a weighted directed graph. In the weighted directed graph, along with the direction of weight is given to you. So from A to B, a weight of 4 is given to you. So from A to B, a weight of 4 is given to you. Since it is directed from A to B and not from B to A, hence from B to A I have written 0. So this way you make your adjacency matrix. This is one way of representation. Another way of representation is the linked representation. In the linked representation, the adjacency list is used to store the graph in the computer's memory. Let's see an undirected graph. As you can see, there are 5 vertices A, B, C, D, E. These are 5 vertices. So I have 5 points over here. Now how is A connected to B? A is connected to B, A is connected to B, and A is connected to D. Hence I have written A is connected to B and D. Similarly, we have B which is connected to C, and B which is connected to D. So we have B which is connected to, also B is connected to A. So B is connected to A, B, C and D. Similarly, we have our E which is connected to D, E which is connected to C, hence E which is connected to D and E, C. Now in all of the cases, the last linked list node will have a null because there is no connection beyond that. So if all the adjacent nodes are traversed, then store null in the pointer field of the last nodes. So over here, since A is traveled from A to B and A to D, so last null is being stored. The sum of the lengths of the adjacency list is equal to twice of the number of edges present in the undirected graph. So keep that in mind. But in the directed graph, since the direction is given to you, now my A is only connected to B. There is no relation between A and D because A does not move from A to D, but so A to B only. But over here, D is again connected to A, so D is again connected to A. But what about B? My B is connected with C and B is also connected with D. So B is connected with C and D. So we can null over here because this is the last one. In a directed graph, the sum of the lengths of all the adjacency matrix is equal to the number of edges. So keep that in mind. In directed graph, it is equal to the number of edges. In the undirected graph, it is twice of the number of edges. So it is an important point. If there is a weight associated with the graph, then we will have three paths, as I have already shown to you. While making a linked list, you will either have two paths. One will have your data, another one will have an address, or you will have three parts where one of them will have an address, another will have an address, and this one will have a data. Over here we have three paths. So one of them is having the data, the weight, and another is the association. Now, what is graph traversal algorithm? The graph traversal algorithm basically means the examining all the nodes and vertices. So, what are the ways by which we can see all the vertices and nodes? So, there are two methods available. One is the breadth first search, and one is the depth first search. In the breadth first search algorithm, the what happens is that we start from the root node. We start from the root node, and then we explore all the neighboring nodes. Then the algorithm, it selects the nearest nodes and explores all the unexplored nodes. So first it will start from one node. Uh, First it will start from one node, and then it will start to explore all other nodes. And then once it has finished exploring all the nodes, it will then again move to the adjacent nodes and see if there are any possibility of other. Now this algorithm follows the same process for each of the nearest nodes until the final goal is reached, which is traversing. So suppose you want to search a term, you have um, so what is the breadth first algorithm? In the breadth first algorithm, it will start examining from the node A, and then all its neighbor. Will start from your first terminal A and all its neighbor. It will see all of them. It will keep on seeing it. The next step, the neighbor nearest to the A is explored. So once it is moved to the nearest to it will be explored. Again from here the nearest will be explored, and it will keep on doing it as long as required in order to find out the term which we wanted to find. In the depth first algorithm, it starts with the initial node of the graph and then goes deeper and deeper until we find the goal that we are looking for, and it's having no children. So it will start from one of the node and keep on moving down till the last point where there is no other children. The algorithm then again moves back and starts from the dead end towards the most recent nodes that yet to be completed. So I will give you a detailed video link for this particular two algorithms. You can see that will clear your doubts. Thank you.